All right, folks, we are tracking Helene as the storm moves along the Gulf Coast and heads towards the southeast. It's expected to gain strength as it barrels toward Florida. For more on the storm and how climate change is impacting hurricanes, let's bring in CBS meteorologist Marina Jurica. Marina, experts expect that this storm is going to make landfall as a Category 3. Explain to our viewers what goes into a hurricane's intensity and how climate change is potentially impacting that.
Well, thanks, Vlad. The increasing intensity of hurricanes is basically rooted in physics. It's the physics of our entire climate system. So hurricanes draw energy from that warm ocean water. And as that climate change causes sea surface temperatures to rise, the energy available for these storms increases. In fact, we estimate that the world's oceans have absorbed over 90% of the excessive heat that's caused by greenhouse gas emissions. Now, this added heat is fuel for hurricanes, making them more powerful. Studies show that for every 1.8 degrees Fahrenheit increase in sea surface temperature, the intensity of hurricanes can increase by about 7%. So warmer water leads to stronger winds and more moisture in the atmosphere, which means heavier rainfall during storms. One of the most significant effects of climate change is its impact on hurricane intensity. Warmer air can hold more water vapor, about 7% more for every degree Celsius of warming. So that additional moisture translates into heavier rainfall, which is why we're seeing more catastrophic flooding associated with all of these recent storms. Now, this week, scientists examined the temperatures in the North Caribbean and eastern Gulf of Mexico and found that they were 1.8 degrees Fahrenheit higher than normal. And human-caused climate change made these temperatures 200 times more likely. This is creating that fuel for the storm, Vlad.
Science and data. What a wonderful thing, Marina. So let's talk about where this extra fuel that is coming from warmer oceans. How does that extra fuel translate into a storm's stronger destructive power? Because that's what we've seen over the last couple of years. There's more intensity and the level of the storms is rising.
Precisely. So these stronger storms are becoming more destructive due to rising sea levels. So global sea levels have risen approximately 8 to 9 inches since 1880, with about a third of that rise occurring just in the last 25 years. So higher sea levels increase storm surges, the wall of water that hurricanes push onto shore, making coastal flooding more severe. Another factor tied to climate change is the slowing of hurricanes. Research indicates that over the past several decades, storms are moving slower, which means they spend more time over land, dumping more rain and causing prolonged damage. This is linked to changes in the atmospheric circulation patterns driven by a warming Arctic. You have a warming Arctic, which is altering the jet streams that steer all of the weather systems across the globe. And one of the more troubling trends that we are observing is how some hurricanes are stalling or just completely slowing down. For example, Hurricane Harvey in 2017 dumped over 60 inches of rain in parts of Texas because it just lingered over the area for days. So slower moving storms can be particularly devastating because they prolong the impacts of heavy rain, wind, and flooding. Now, tropical cyclones can cost billions of dollars. In fact, since 1980, they have caused more than 1.4 trillion in damages and caused nearly 7,000 deaths. Now, with Helene, Vlad, we're not as concerned about it stalling out, but we are concerned about its very rapid approach to the Florida coastline and the impacts that it will have because of that.
Wow, Marina, I got to say, in all the years I've been doing this is the most interesting weather analysis and report I've ever seen. My eyes, I was glued to everything that you were saying. Really, thank you very much.
Thank you so much.
That was excellent. Appreciate it.